So, my name is Alvaro, and I'm presenting the Charge Control-Statistical solar system. Solar analysis, sorry. My advisor is Dr. Damu, and I also have so much help from Mr. Aaron Weed right here. I have to mention you. Okay, so here we go. So energy conservation and in today's day is increasingly important in the past few years. It's a topic that reaches all phases of life. And the price of electricity has also been constantly increasing and shows no sign of decrease. Especially oil and gas electricity. The price of oil and gas electricity produced. My product, the statistical solar analysis, offers a robust, energy efficient alternative to the grid. My project has charge controlling, we need charge controlling, stabilizing power. Coming from the solar panel, there could be a cloud passing and change the power coming from the solar panel into the batteries. So you need to make sure you add a voltage regulator so that the voltage is not going to damage the batteries. I put, sorry. Okay. I'm sorry, it's been a while. So my product periodically checks the voltage that the battery has stored so that once the battery is fully charged, then it stops charging it. You know, overcharge can damage the battery. And it also checks when it's overly used or almost getting drained. You never want your battery to be fully drained because that might also damage it and decrease its lifespan. So you can go ahead. So you want to make sure that you're checking. My device is also going to check when there's enough power coming from the sun to be able to charge the battery. So it stops the charge when there's too much. If there's too much, it's going to stop it, but it's going to be regulated. So actually, it's never going to stop. But if it's ever below what the batteries need, then it's not going to charge it again. The device also grabs all this data and is going to be storing it in a database. Why would we want this? Well, you want to be off the grid as much as possible because the reason for having solar panel is to save money. You don't want to have to be paying the electric bill. With my product, you'll be able to make your money back for paying for the solar panels within 5 years. And I'll tell you why. One, you'll be saving money, so you won't be paying the electric bills. And two, you will be able to possibly make money from the solar company, from the electric companies if you're feeding the grid. Okay, so what the database will be doing is it will be checking every 15 minutes. I have my checking every 15 minutes what is the efficiency of the panel. So, and it's storing it in the database so that you can see which panels is working best at what time, what day of the week, or what weeks is working longer, or what time of the year. All this data can be graphed. I'm using the Raspberry Pi to connect to the database. So first, I was going to need some solar panels to test my data with, to test my product. HCS12 I use for digital converter and the LC display, charge controlling. Since it's more robust, the Raspberry Pi doesn't take much amperage or voltage, so it can easily get damaged. So you have to be very careful. I was going to need voltage regulation and transistors for the I also use transistors for regulation and for the switch. At first, I started using assembly, but I didn't feel too comfortable with it, so I changed over to C language. And it was much easier since C language it's more English. It's better than using assembly, to me. So I programmed the ATD converter with the with the HCS12, and I programmed the LCD display to display when is the battery charging and when is it not charging, just so that the user can know. And I use my Raspberry Pi also for another ADC conversion to connect to the database, and I used a lamp configuration, and I'll tell you exactly what that is. Before I tell you what the Raspberry Pi, the Raspberry Pi is this device you see over here, and it uses an ARM application processor. It has dimensions of 86.60 by 5621 millimeters. It weighs about 45 grams, and this one is 512 random access memory, 512 megabytes of random access memory, only costs $35. LAMP configuration is using Linux operating system, Apache, which is the worst web server software, MySQL, which is the database server, and PHP is either PHP, Perl, or Python. I use Python to program my code. MySQL is the leading open source database management system. It's also multi-user and multi-threaded database management system. And it manages millions of queries every day, including YouTube and Wikipedia. And it runs on the most important database and the most important operating system, BSD Unix, Linux, Windows, and Mac, which was what I used. When programming in the Raspberry Pi, I was going to have to program from the command line and not an actual editor. When I was doing the installation, everything was going off from the command line. So that's harder in the sense of you're not going to spend much time clicking on icons, which is easy, but the advantage is that the processor has more time to serve up information, which is technically what you want. You know, if you're running millions of data for a big company, then you want this information to be put up as soon as possible and almost instantaneously. So the Raspberry Pi, sorry, something erased here. It's probably your computer. It was there a few minutes ago. Okay, so a disadvantage of the Raspberry Pi is that it has no HDD converter. So I had to get another device that was ADC friendly to connect to the Raspberry Pi. So I used the MCP3008. I'm sorry for the data that's not showing here. I don't know what happened with that. And so the MCP3008 makes the Raspberry Pi friendly, which can be interfaced with the SPI 4 pins only. MCP3 has 8 channels, and it again uses 4 pins from the Raspberry Pi. The Raspberry Pi has 16 GPIO pins. So you can use 4 of these devices to control 32 solar panels, which for a home, actually no, not for a home. For a home, the average home needs about 14,400 watts per day, and that's about 80 panels. I mean, 80 of the panels I had that I was using is 175 watts. So I would need about 80 panels to be able to power the home for a whole day. So in that case, I would just get more Raspberry Pis with more of these MCP3008. Also, I mean, if there's, I was searching and I couldn't find. I was looking for a 16:4 decoder, but I couldn't find any. And what that would do is that would give me 16 for each input analog. That's about 120 something panels I could connect, which is more than enough for a home. Okay, so essentially, the Raspberry Pi collects a digital input from the MPC308. That's a DC signal. Sends it to Python. Python connects to my SQL database, and the data is added. When the user goes to the PHP script, the data is placed in the forum, and they can see how the panels are performing. Python was a very easy language to learn. Again, next to Aaron, I had never seen Python until I began this project, so it took some time getting it. And one thing I noticed about Python is they don't use, you say like in C, curly braces are very important. In Python, what's important is the indentation. So you know that. And Python is also used a lot with web servers, websites, game frameworks, and desktop applications, which is basically what I'm revolving around for this project. So, the Raspberry Pi, once I installed PHP, Apache, the web server, and MySQL, Python, I had to connect to a database host. And I also used Aaron's database host, which is very, very easy to use, to create tables in, send data to, sort the data, and also extract the data from for you to use. This is an example of my data. Right now, as we speak, I have the panels up on the roof, and it's collecting data. And this is when I first started, and this was today. You see the date. It checks every 15 minutes, and it dots down for panel 1, how much voltage is coming out, for panel 2, how much voltage is coming out, at what time. And you see panel ID, panel location. What that is, well, if you have a set of panels up in your rooftop and you have some in your backyard, then you're gonna need to have different locations because you need to have the information organized so that when you go on the net and see how your panels are performing, you know exactly where to go. So let's say panel 3 is messing up in location 4. Hey, hey, Dr. Zadi, panel number 3 is not as efficient as the rest. Can you go check what's going on? Or you go and maybe a bird pooped on it, or a golf ball hit it or something. So you just want to make sure you're always having the most efficient coming out of the solar panels, and that you're not wasting your money, rather making it. Again, this is the website is easy to sort it by just clicking on panel ID. It's going to set it up panel 1, show all the information for panel 1. If you do it by location, it does the same for voltage and for the time. 16 GPIO pins, I already spoke about this. The homes. It's here, I don't know why I keep on going there. Okay, so this is an example of my analysis. These two tables, they were just from the first time when I first turned it on. It was already like 7 or 5 p.m., so I didn't get much data. This is basically, you see at around 6, 7, it started going down, and then it went over to the night, 12 a.m. This is panel 2. This was allocation 1. I had them inside the room 208, facing the window. This picture was location 2, and I had them against the wall. So the sun comes up from this side, so as it was coming up, we should see, I'm going to show you the next graph, we should see on the next graph that when the sun reaches that side, so later on in the day, the solar panels should increase. So it's pretty bad. Again, it's because it was inside room 208. You can't get much power inside a room. So this is panel 1, panel 2. Started off low, very low. Then later on in the day, when the sun was all the way at the west, the window was some power was able to come in through the window and get some power. Then at 12, it stood at 5 because the room lights were on. These guys were probably working there till very late. And this is just a comparison of both panels at location 1. Okay, so this is in the rooftop. This is location 3. And location 3, I should be able to get the most power because the sun, as soon as it gets out, it's getting shone on the panel. and I have it in a position where it's almost perpendicular with the panel and the sun. So this is how the data looks for panel 1 or panel 2 at about 5:30 in the morning when the sun came out up in the east. You see from 12 a.m. the panel is recording data every 15 minutes. Once it hits like 7, 8, goes right back down. Same for panel 2. So this tells us that location 3 was the best location out of the 3 locations. I mean, it was purposely. I know that inside the lab there wasn't going to be much coming out of it. This is the analysis of both panels. So ideally, if you had 20, 30, 40, X amount of panels, you'll be able to compare each graph and say, hey, what's wrong with this panel? Why isn't it as efficient as the others? Maybe I should go and check out what's going on. I'll change the location. The stakeholders for my project will be companies. Once again, companies who install panels will benefit from this product because it will help them keep customers. Not only will they install the product, but for an extra charge, a month or a year, they can manage their systems, and you might not have to worry about how your panels are doing because somebody else is doing it for you. Once in the company they see that